So next we'll discuss about the alternating current through a pure inductor. So in the previous case we have discussed when alternating current through the pure resistor, right? So both voltage and current will be in phase. So obviously whatever the power you want to get, it will be always a positive. So it will consume the power. So that's why in case of a resistor we want to get the power in the form of a heat dissipation. It will be always consuming the power. So for this, let us consider a simple circuit which will contain an inductor which will be connected to a voltage source. So V will be equal to Vm sine omega t. So if you consider this, right? So V will be equal to Vm sine omega t. And if you want to write the equation for the current, so let us consider the basic equation for the EMF induced. So when an alternating current I flows through the inductance, a EMF will be induced in it. So we can write your EL will be equal to minus L into di by dt. And whatever the EMF will be induced, it will oppose the cause of producing it. So your V will be equal to minus EL. So we can write it will be equal to L into di by dt. Now we want to write the equation for I. So your di by dt will be equal to V by L, or di will be equal to V by L into dt. Now if you integrate on both the sides, we are going to get I will be equal to, here integral of, in place of V we can replace that one by Vm sine omega t, and denominator we have is L. So from this, so what we can make is, we can write the equation for the current. So your I will be equal to, so Vm is constant and L is also constant, we can take outside, it will be integration of sine omega t. If you consider the integration of sine omega t, if you integrate that one and if you further simplify this, so what I am going to get, your I will be equal to Vm by L, and sine omega t, if you are going to integrate that one, it will become minus cos omega t divided by omega. So this will become minus Vm by omega L cos of omega t. So the cos omega t can be written as, this will become Vm by, we can write this one as XL, inductive reactance, where XL is given by omega L. So cos omega t in terms of sine, if you want to represent, because the voltage is in the terms of sine, that's why we want to represent current also in terms of a sine. So this can be written as sine of pi by 2 minus omega t. This is minus sign is there. So now if you want to eliminate that particular minus sign, so your I will become Vm by XL. If you take the negative sign inside, it will become sine of omega t minus pi by 2. So this is what the equation, what we are going to get it for the current. Voltage equation already we have taken. So the voltage equation we had is Vm sine omega t. Now if you compare with both the voltage equation and the current equation, along with omega t, here we don't have any angle. Let us assume this one as 0. But if you consider with the current, the angle we got is minus pi by 2. So from this we can make the conclusion that if you take voltage as a reference, since the current lags by an angle 90 degree, for a pure inductor, your current will lag the voltage by an angle 90 degree. This is how we are going to get, in case of an inductor, your current lags the voltage by an angle 90 degree in case of a pure inductor. Right? So that's what we have. If you consider a voltage as a reference, the current will lag. If you consider a current as a reference, your voltage will lead. Both are one and the same. With respect to the voltage, your current always lags. So that's why if you want to write the waveform for that, so initially we will start with a 0 because we have a sine omega t with respect to a voltage. So when omega t is 0, the voltage value will be 0. But if you consider with the current, so your current I will be equal to Im sine omega t minus pi by 2. So when we are going to substitute omega value as 0, omega t value as 0, the sign of minus pi by 2 we are going to get. That's why it will be negative value. Next, when omega t value is 90 degree, sin 90 will be 1. So we are going to get the voltage value as a maximum. But in case of a current, when you substitute omega t value as 90, 90 minus 90 it will become 0. It will give you sin 0. So current will start at 90 degree. So you can observe here, voltage is starting at 0, but the current is starting at 90 degree. So both have a phase difference of 90 degree. That's why we are going to get the waveform like this. Now, let us derive the equation for the power. So as it is, so we know that a P is given by Vi. So V is given by Vm sine omega t and I is given by Im sine omega t minus pi by 2. So if you are going to consider this, and if you want to multiply both, it will give you Vm sine omega t, and sine of omega t minus pi by 2 can be written as minus cos omega t. That's why we can write this one as minus Im cos omega t. If you further simplify, this will give you minus Vm Im sine omega t into cos omega t. But we know that what is sin 2 theta is, which will be 2 sin theta into cos 2 theta. Using that relation, we can write this sin omega t into cos 2 omega t as sine of 2 omega t divided by 2. So it will be minus, we can write this 2 as root 2 into root 2. So this will be Vm by root 2 into Im by root 2 into sine of 2 omega t. So Vm by root 2 and Im by root 2 is nothing but the RMS values. So I'm going to get the power equation as minus Vrms into Irms into sine of 2 omega t. This is what the power equation, what we are going to get for the pure inductor. So obviously here, when omega t is 0, sine 0, we are going to get the power value as 0. When omega t is 45, 2 omega t will become 90. At that case, you are going to get the power value will be a maximum. Again, when it reaches 90, so sine 2t, it will be 180. Again, it will become 0. Then again, it will go to the negative cycle. Like that, this will be fluctuating in nature. Now, let us see the waveform, how the power will be varied. Now, if you consider, first, if you want to write the waveform for the power, so P is given by V into I. That's why first we should write the V and I. So this is the V what we have. Then the I will lag the V by an angle 90 degree. If you are going to consider that, now you can see here, during this condition, the voltage is positive, but the current will be negative. Anything multiplied by positive into negative, the resultant will be a negative. That's why I want to get the power as negative here. During this condition, the voltage is positive and the current is positive. So both are positive. I want to get the power value as positive. Next, a voltage is negative, current is positive. The resultant will be a negative. Next condition, the voltage is negative and the current is negative. Minus into minus will give you the positive value. So now you can observe that one positive cycle of power I want to get, one negative cycle of power I want to get with the same magnitude. So the resultant power will be 0. So we can come to a conclusion that the power consumed during the pure inductor, or the average power during a pure inductive circuit, will be always 0.